right, so here we are in the problems in the book. Now, some of these are going to be easy to show on the computer. Some are going to be a little bit more difficult. So we'll do the best we can, and that's when we're going to have to switch back and forth between the big screen and little screen on the PowerPoint. So on this one, it says, at each labeled point on the graph, identify whether the instantaneous rate of change is positive, negative, or zero. Okay, then we're supposed to say, is the graph steeper at point C or point E? And then is the graph steeper at point A or point C? All right, so if we look at this, if we drew a tangent line here, that would be what its slope would be. So what is A? Well, A looks like it's going to be A is negative. So that's a negative slope. Now B, here we're going to draw it straight across like that. Now again, I'm not going to draw it just because it's going to look bad. And so B looks to be having a slope of 0. Now C, now this time this is an inflection point, so it's going to kind of go on both sides of the thing, and so it's going to kind of go like that. And what's it going to be? Well, C is going to be a positive slope. D, we're back to, it's a 0 slope. Well, so we'll say and D. And here we're going up again like this, and so that's a positive slope. So we'll say E and C here, okay? So we have A is negative, D and B are 0, and E and C are positive. Now, is the graph steeper at point C or E? All right, so E is here, and C is here. So to me, it looks like it's steeper at E because it's kind of like this. This one is like that. So it's I don't know. It's um, more vertical because if you look at the how the curve of this is, that's kind of more flat. This is kind of more vertical. So I'm going to say it's at point E. Now A or C, well, A is more steep looking to me going down. It's going to be a negative slope, but this is more gradual compared to this point coming down. And so I'm going to say it looks like point A. And again, it's really hard to discern unless you could tell, what is the actual slope values, then we'd know for sure. But then that wouldn't be uh, uh, the hard part, trying to decide if that's steeper there or steeper here. But that's coming across here. This is coming down like that. All right. So over what intervals is the output increasing? Okay, well, that means we have an upward slope. So it looks like it's going to be increasing from about here to about here. So it looks like from about 0 up through maybe 4. So I would say 0 less than x less than 4. Now, where is it decreasing? Well, it looks like we only are going to 2. So from -2 up to 0. So -2 less than x less than 0. And it looks like from 4 to maybe 6.5. So 4 less than x less than 6.5. Again, who knows? Maybe that's only 6.25, but I'm going to guess it is 6.5 and go from there. Okay. Now we're supposed to estimate where the slope is the largest. Now here, that's kind of got the same slopes here and here, so it looks probably like some kind of cubic. And so I would say, because of the fact that we're going to have to come steeper through here than we would anywhere along here, maybe, I'm going to guess it maybe is about here, maybe at 0.2. So x is approximately 2, maybe. I don't know. That's kind of what I would guess. But again, it's hard to say what the steepest slope is unless we actually could, measure it and do all those things along the whole way, or we knew the curve and we could actually figure it out that way. But I'm going to say it's about 2, which is at the inflection point. All right, so again, we're supposed to identify the input intervals where its slope is positive, negative, or 0 for all the input values. Okay, well, what about this one? Well, the slope here for this is continuously negative, so it's going to be negative for all input values. So that one, we don't have to switch anything. It's just always going to be negative. Now, maybe we should go ahead and do the rest of it. For each interval identified in A, indicate whether the steepness of the slope increases, decreases, increases and then decreases, decreases then increases, or remains constant. Well, that looks like a purely linear line, so it better remain constant. Okay, so the slope is always going to be the same no matter what. All right, what about this one? Well, this one going from left to right, it's decreasing the whole way. So it's going to be basically, it's going to have a negative slope over the whole area again. So it's going to be over the whole input, it's going to be negative because if you draw a tangent and tangent and tangent, 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 it's always going to be a negative slope. Now, what does the steepness of the graph increase, decrease? So here, what's it look like? It's looking like what it does is it's pretty steep here, and then not so steep here, and a little less steep here, a lot less steep here. Then the further over we get here, so I think it's basically, I would say, the steepness decreases as we go. Okay, so as we go to higher x values, it looks like it's getting less steep because that's pretty steep there, but over here, that's pretty flat and almost going to go to zero. And then once, if this is, goes to zero as we go out further and further to x, then it's going to get a horizontal slope almost. So I would say that would be the case for this one. All right, so let's pause there and we'll come back for some more.